what we know that glycans change a lot with aging. So we know there is a correlation. So when people are young, we mostly see glycans which are generally suppressing inflammation. And as people are getting older, we see glycans which are more promoting inflammation. We don't have clear evidence that if we change glycans, we will suppress inflammation. So this is not something we can consider to be scientific truth. But there are indications that, for example, if you give young immunoglobulins to older people, you have a suppression of inflammation. There's some molecular evidence that glycans attached to IgG can promote or suppress inflammation. So what we believe is that glycans which change with aging are actually also driving aging. So they're not only the biomarkers which change with aging, but they actually promote this low-grade systemic inflammation, and then through a process called inflammaging, they actually contribute to the different types of tissue damage which we see with aging. Because what we see with aging is that different organs and different organ systems start malfunctioning. So they're not as good as they were before. And one of the potential causes for that is a kind of accumulation of damages, which also happen through inflammation. Because it's important to understand what is inflammation. So normally, if something attacks us, a virus, a bacteria, we want to eliminate the damage, eliminate the threat. Because if bacteria feed on us, they can eat us, they can kill us. So we want to kill them. And we do it by activating inflammation. So we are sending all the weapons we have in our arsenal, the immunoglobulins, the different natural killer cells, macrophages, and so on. And they all come to the site where there are bacteria. Then there is war, meaning immune system fighting bacteria. And usually we see it as a kind of swelling, something becomes red, becomes warm. And then we eliminate the threat and rebuild the damage. And we need it. We need it for survival. But for inflammation to be beneficial, it has to be resolved, meaning we have to activate it and then we have to shut it down. And as we are getting older, we have problems in shutting it down. We have problems both in activating and shutting it down, and we have more and more of something which is called low-grade systemic inflammation. So instead of explosion of inflammation, we have a slight inflammation going on, and it's still destroying our tissues, killing our cells. It has to be rebuilt. It leaves a little bit of scars each time. So each fight causes a little bit of damage. Low-grade systemic inflammation is causing a little bit of damage everywhere. And as we are getting older, it consumes a huge amounts of energy. And one example how important this can be is, for example, there are many people who take IVIG preventively. For example, also, I think that Brian Johnson now, what he's doing regularly, he's getting rid of all his plasma and just replacing it with albumin and IVIG and immunoglobulins. So immunoglobulins which are suppressing inflammation. So I know a number of people who would take IVIG every autumn and immediately see a beneficial effect because of the immunosuppressive effect, not the inflammation suppressing effect. So by suppressing inflammation, we are saving all the energy which is consumed in that war. Because all these proteins we invest, all these cells, they cost a lot of energy. If we save it, we have energy for other sources. So by suppressing inflammation, we save energy, we can use it for other things. I think one of the major problems we have in medicine today is that everything we know is based on an assumption of a standard human. Meaning we take 100 people, give them a specific drug, and then decide whether this drug works or not. And we know that the majority of drugs do not work in majority of people. And it's normal, you have a disease, you go to your physician, you get a drug, it doesn't work, you get another drug, then they find you a drug which works. So we know that we are all different. And the same is for lifestyle interventions. Somebody recommends keto diet or a high fiber diet or whatever kind of diet. And people are usually extremely passionate about the diet they believe in, because most often they have seen it to be really effective in some people. But in some other people, the same diet may not have an effect, or the same type of physical activity. So we are all different, but we don't know which of these things really works for me. Because I don't care about the standard human. I'm interested about me. So what kind of drugs should I take? Do I need any supplements? What kind of physical activity? And either we can wait for 20, 30 years to see the effect of what we are doing, or we can try to quantify it in some way and see the effect faster. And one big advantage of glycans compared to, for example, genetic testing or even epigenetic testing is that they really respond to different type of interventions. So you change your diet, your glycans will change. You change your physical activity, your glycans may change. You take a specific drug, your glycans may or may not change. So these biomarkers give us insight into what we cannot see with our own eyes, or which we cannot even see in the regular blood tests or other tests which are being done. For example, we know that glycans will change up to 7 years before people develop insulin resistance. So, and this is still a few years before somebody gets diagnosed with diabetes. So instead of waiting to get diabetes, 10 years earlier, you can get an indication, we are changing, we're moving in the wrong direction. And then you can make a decision. Okay, I go in this direction, I'll wait for 10 years, then I'll get diabetes, I'll take drugs, I'll have diabetes, but I do it the way I want. And some people will do it this way. Or you make a decision and say, but I'm becoming ill because of the way I eat, because of the lack of physical activity, and I don't want to do it. I will change. I will change my diet. I will change my sleep pattern. I will change my stress control and prevent, or at least postpone disease. Because I think the big problem when we talk about longevity is that there are many of these, I call them longevity freaks, which claim we will live forever, we will never die. The idea of longevity is living forever. So I understand that some people want to live forever, but as a biologist, I think there has to be change, generations has to change, otherwise there is no adaptation. So I think what is the most important is that we are happy, healthy, functional for as long as we can. And then we just easily leave the planet and not spend 10, 20, 30, 40 years being sick, being in pain, being unhappy. So this is longevity. Longevity is staying healthy for longer. And some people also call it, let's focus on a health span and not on a lifespan. So, the life is not really valuable if you don't have your health. You have to be realistic and admit that we do not understand life at the molecular level. We just know a little bit of some of the things that we can measure. And we know very little. And it would be extremely arrogant to say that we understand what happens when we change a tiny little dot in this very complex network. And the way forward is, at least let's see what we can measure. Let's develop tools, let's develop methods, let's develop analytical approaches, statistical approaches, AI methods, to integrate these things which we can measure for each individual person, and then try to find some logic, try to understand a little bit more about life. And this is what we are trying to do by adding the glycomic layer to other omics, because nearly everybody can measure the genome. Analyzing the genes, it's so easy today. A couple €100 and you have your whole genome. Epigenetic testing is widespread. More and more people do metabolomics, although in metabolomics, usually only a fraction of the metabolome is analyzed. Now the proteomics is becoming popular, measuring, but then again, you are just quantifying the level of a couple hundred up to 1,000 proteins. but they're lacking this the most complicated layer of post-translational modification, where glycosylation is the most elaborated. And glycosylation integrates genetic information, epigenetic information, and environmental factors into chemical structures, glycans, which we can quantify. So by measuring glycans in different people, we can see both part of their genetics, so why are they different because of these billions of years of evolution, part of the epigenetic information, meaning everything what me, my mother, and in some cases even my grandmother was experiencing while I was within them, because we know that the egg cells are formed already in the fetal stage. So actually the grandmother of my mother affected epigenetics in my mother. And then everything I did during my lifestyle, everything I did during my life with lifestyle, eating, physical activity, what I'm thinking, extremely important. So especially in young people, we see very strong effects of psychological well-being. Stress, sleeping, whatever, it can have very strong effects on our immune system. And then we put it all together and we try to understand why is somebody moving toward the disease and somebody else is not, and how can we change this trajectory and identify the problem early, fix it, and then postpone the disease.